Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous topic we have discussed about the isotopes and as well as the characteristic of it, and now in this topic let me talk about the isobar as well as the characteristic of the isobars. So what are isobars? Let me talk about that in this topic. So friends, talking about the isobars, it has a definition, that is the atoms of different elements which have the same mass number or atomic mass number but different atomic number are called as isobars. For an example, suppose if we consider potassium. Potassium has an atomic number of 19, and suppose in that case we have got to know that is the atomic mass number is 40. Similarly, suppose if I consider the another element, suppose calcium. So calcium has an atomic number of 20 and the atomic mass number is, suppose if it is found to be 40. So here these are the two elements, they have the same atomic mass number, that is 40 and 40, but the two elements have different number of protons or different atomic number, and that makes these two elements to be called as isobars. So these are the example, but we are going to talk about more in detail about the isobars with the help of the characteristic of the isobars. So what are those? Let me talk about that. So here I'm going to talk about the characteristic of the isobars. So starting with the first point, we have these are the atoms of the different elements. This is the first point, and that is what we have discussed in the example. Talking about the next point, we have they have same mass number but different atomic number. Even that is what we have discussed. Talking about the next one, that is they have different number of electrons, protons and neutron also. So here let me talk about this point and let's see that how basically isobar is different from that of the isotopes. So friends, these are the three examples that is we are going to discuss about. So here basically you could find that is these all are the different elements, and that is potassium, calcium and argon, but here there is a similarity, that is you could find the same number of atomic mass in each case. So let us try that is how we can calculate the number of proton as well as the number of neutron here. So here we can find for potassium we could get that is the number of proton, which also represents the atomic number, is found to be 19. Similarly, the number of electron will also be 19. But here suppose if we have to calculate the number of neutron, so for that we have a formula, that is what we have discussed in the previous topic, that is A is equals to Z plus number of neutron. So here basically the Z, that is the atomic number, which is also represents the number of proton, it has been found to be 19. So here suppose if we have to calculate the number of neutron, but here we also have the atomic number, but here we also have the atomic mass number or mass number, that is 40. So while calculating this, we could get that is the number of neutron as 14 minus 19, in this case it will be found to be 21. And now let's talk about the calcium. So here basically the number of proton is found to be 20, because number of proton is nothing but the atomic number of a particular element. So similarly the number of electron, it will be 20. And suppose if we have to calculate the number of neutrons, so for that again we will apply the same formula, that is A is equals to Z plus number of neutron. So here the Z is nothing but the number of protons is 20, and here basically we have to calculate the number of neutrons, but for that we already got to know that is the atomic mass. So here basically we have already got to know that is the atomic mass number is 40. So therefore I am writing here as 40. So therefore the number of neutron is nothing but 40 minus 20, which is 20. So here let's talk about the argon. So for that we have got to know that is the number of proton is found to be 18. Similarly the number of electron is also found to be 18, and here we will apply the same formula, that is A is equals to Z plus number of neutron. The Z, that is the atomic number, is found to be 18 plus the number of neutron, that is what we have to calculate, and for that we have the atomic mass number, that is 40. So here the number of neutron will get as 40 minus 18, which is 22. So in this all example, we have got to know not only the number of neutrons are different, but the number of protons as well as the number of electrons are also different, which makes all this to be called as isobars of each other, because they all have the same atomic mass number, but they have different physical and chemical property depending upon the number of proton and the number of electron they have. So therefore this was related to the third point, and now let me discuss about the next point of the characteristic of the isobars. So the next point is they have different physical and chemical properties, obviously because these isobars are of different elements, and that's the reason that they will have a different physical and chemical property. And talking about the last one, that is they occupy different position in the periodic table. Obviously potassium, calcium and argon, the example that is what we have considered, obviously they have a specific place in the periodic table, but since all the elements are different from each other, they will have different position in the periodic table. So therefore this was all related to the isobars and the properties related to the isobars, and that's it. So thank you friends for watching this video. I hope you have understood this video very clearly, and I hope I'll see you next time. Till then, don't forget to subscribe Ekeeda channel. Thank you so much.